Hello, thanks for joining us today. Today we're going to be talking about lesson 8-5, part 2. If you haven't watched part 1 yet, please do so. It's imperative that you watch that first. In that video, we talked about how we can create trig functions that are defined for any angle by thinking of them as circular. Angles are circular, not as just inside a triangle. If we do that, we might as well let r equals 1. Let the radius of each angle be 1, and we could get something nice called the unit circle. Now, the unit circle has a lot of useful techniques for memorizing. We're mostly going to use the unit circle to find angles where things are not that nice. So if we have sine of pi over 6, that's pretty nice actually. If r equals 1, each of these guys just becomes whatever the y coordinate would be. So if that guy is 1, and that's pi over 6, we're talking about a 30-degree angle. The only way to hit pi over 6 with an angle of 1 right here, if that ratio has to be 2 to 1, this side would have to be 1/2. Okay? So the y coordinate would just be 1/2. Now, it's not that useful for that. You might as well just memorize the reference triangles for that. Reference triangles. The unit circle is really much more useful when we're talking about sine of 0, cosine of 0, or any of these other angles where we can't get a reference triangle. So for sine of 0, we're talking about if my angle was flat like that. This is for B. If the angle is flat like that, what is the value? What is the y value of that coordinate? Well, that coordinate on the unit circle is 0, 0, so sine of 0 is just 0. Sorry, that coordinate is, I'm so sorry, that coordinate is 1, 0. The coordinate for pi over 2, 0, 1. The coordinate for pi is 0, negative 1, 0. I'm just messing up today. And for 3 pi over 2, we're talking about 0, negative 1. So, based on those, and the fact that sine is just the y-coordinate, cosine is just the x-coordinate, and tan is this, can you fill out the rest of the table? I'll wait. You should try to fill out each of these. These are not that bad. 3, 2, 1. Cosine of 0, just the x-coordinate, 1. Sine of pi over 2, 1. Cosine pi over 2, just the x-coordinate is 0. Sine of pi, y-coordinate is 0. Tan of pi. Now, tan of pi should be the y-coordinate divided by the x-coordinate, which is 0. A lot of people mess up tan. It's that easy. Think about what coordinate that would be. X-coordinate, y-coordinate over x-coordinate. Sine of 3 pi over 2, just the y-coordinate. Cosine of 3 pi over 2, just the x-coordinate down there. Cosine of pi, negative pi. Ooh, now negative pi, we're going to start here, and we're going to rotate all the way around. Wow. We're going to try to rotate all the way around pi radians. So we get to here. Oh, look, it has the same coordinate. What a surprise. Cosine negative pi, therefore, is just the x-coordinate of that point. Negative 1. What about tan of negative pi over 2? Rotating negative pi over 2. Man, I was doing so well there for a while. Would stop right here. It would be using this coordinate. It still would have the coordinate 0, negative 1. We'll put the y-coordinate over the x-coordinate, and we get what? We get negative 1 divided by 0. If you have negative 1 cookie and you split it with 0 people, undefined. Not technically D&E. I'd rather you write undefined. Tan of pi over 2, tan of negative pi over 2. These are both undefined. That's tan, if you can read my handwriting. Oh, gosh. Ugly, ugly handwriting. Tan of pi over 2 equals undefined. That's it. So again, the main use of the trig of the unit circle is to get these angles done, where we can't draw a triangle. There's no way to draw a triangle when it's just one line. There's no way to draw a triangle, a right triangle, where there's two right angles. That's the problem here. End of story. Here we go. Let's go a little further. Sine and cosine are the two most important trig functions. If you can memorize just sine and cosine, you get all the other ones. You can verify this. If we have, I don't know, opposite over hypotenuse divided by adjacent over hypotenuse, keep, change, flip. Whoops. And then these will cancel. Okay. Memorize these. You should be able to build tan and cotan out of all the other functions. That's all this is saying. Not that much difficult. Just more stuff to memorize, more stuff to review. If you don't have it memorized, please ask me. Again, I can help. All right. If sine of theta equals 3 over 5, find the possible values. You're probably going to miss this if you first try it yourself. Let me do the first one. If you feel that confident, pause it and see how you do on the first one, and then try the other two. 3, 2, 1. So we want to make triangles that would have that property, that sine is 3 over 5. Now the triangle most people find is in the first quadrant, our happy place. And if we have an angle that gives us 3 over 5, it means the opposite side was 3 and the hypotenuse was 5. Okay? Now, the one issue with that is this will also have a dual triangle. Another triangle that could give us that value of the ratio would be this. It's evil twin triangle. Sorry, that's my flux. It's evil twin triangle over here with that angle, where the same height and same radius, but different x value. Now that's the part that people sleep on. That's the part people forget. So notice that both of these would have the same y value and the same radius value, but they have different x values. And what's that x value? You should have noticed that this is a 3, 5. If the hypotenuse is 5 and the one side is 3, the other side is 4, and this side is 4, 2. Are they both 4? No. This is negative 4 because it's in quadrant 2. It's on the negative side of the x-axis. Okay? So cosecant of theta for this triangle has to be 5 over 3. What about for this triangle? Has to be 5 over 3. There's only one option here. Now what I'm trying to make clear, if that all looks stupid to you, please try these two, because you'll find that these two have multiple options. 3, 2, 1. Cosine of the red one, for the red one, cosine would be adjacent over hypotenuse. All well and good. But over here in the orange triangle, adjacent is different. So we get two possible values. Both are possible values of cosine. Both are possible values of cosine. Both. So if you don't understand how I got that picture, rewind it, watch that again. It's because all I know is the y-coordinate is positive, but there's two places where the y-coordinate is positive. Tan. In the red triangle, tan has to be opposite over adjacent. In the orange triangle, tan has to be opposite over adjacent. Still two triangles. So there's still two possible values. Cosecant only has the one. If you're thinking, wait, aren't there triangles everywhere? If you're seeing all these numbers fly by your eyes. No, because this would be negative 3. Negative 3 and 5 does not make positive 3 over 5. Remember, this has to be positive. This has to be positive. It doesn't matter if it's in quadrant 3. Radius has to be positive. Hypotenuse has to be positive. So this purple triangle is not a possibility. So solving these for angles has to work backwards. That's what it says at the top. Make sure you work backwards. Make sure you try to find out your reference triangle and work backwards. So here we go. Starting with -2/3, root 3. Cosecant is which two sides? Think about it. Cosecant is opposite and hypotenuse. Cosecant is 1/sine, so it's actually hypotenuse over opposite. Now the hypotenuse can never be negative, so it must have really been 2/-√3. So we're talking about the radius over the y-coordinate, if that helps you. If the radius is 2 and the y-coordinate is -√3, we have two places where the y-coordinate could be -√3. We have this in quadrant 3, and we have this guy in quadrant 4. Always look for these evil twin type guys. And so now which angles would get us this? Well, if we notice it's root 3 and 2, even if it's negative root 3 and 2, that should immediately make you think of a 30, 60, 90 triangle or a pi/6, pi/3, pi/2 triangle. For this orange one, we're thinking about this angle. So in this orange triangle, I'll draw it again for you down here. If that's root 3 and that's 2, then that must be 1. So this was the 30 or pi/6, and this must have been pi/3. So if we have a full half revolution, it's pi plus pi/3. So x was equal to pi plus pi/3. It's pi plus a little bit more, which would actually be 4 pi/3. There's other ways to do this. The other option is you memorize that the pi/3 angle over here is 4 pi/3. I find that a little distasteful, to be honest. And now this red big ol' angle, it must have been also a pi/3 angle, because it's still across from the root 3 side with hypotenuse to that. So that also must have been a pi/3 angle. Now I have some students who want to say, oh, I can figure this out, it's easy. The easiest way is to go from here, which is 2 pi. So the x for the red guy, that would be x, is 2 pi minus root 3, minus pi/3. Would actually be 5 pi/3. So those are my two angles. I know that's hard. I know that's hard to work backwards. Please try it out with B. It would be really bad if you couldn't do this all by yourself. We're going to have plenty of time to work on it, but you need to try it out yourself. 3, 2, 1. The first thing you should notice with B, and feel free to pause this if I give you a hint, and that makes it feel like it's clear to you, is that cotangent is not written as a ratio. We want cotangent as a ratio. Cotangent should be adjacent over opposite. I'm sorry, opposite and hypotenuse sound similar to me. Adjacent over opposite, which is x over y. So we're talking about my x should be root 3. My y should be 1. So the easy one to get is in the happy quadrant, where my x is root 3 and my y is 1. Now, but unfortunately, we have the evil twin. There's another way to get root 3 and 1. That way would be to use evil negative numbers. Numbers like negative root 3. So that's to be the x, and negative 1. Think about it. If I did negative root 3 divided by negative 1, do I get the same exact value? Yes. So over here, The blue triangle should have been easy. The light blue one is just our happy quadrant 1 angle. It's the quadrant 1 angle that's across from 1. 1, 2, root 3, run root 3, 2. Across from the 1 should be the smaller angle, the bigger denominator, pi over 6. And then again, this blue angle is definitely also pi over 6, but he's over here in quadrant 3. Quadrant 3, pi plus pi over 6. Pi plus pi over 6, write it out if you have a hard time, is 5 pi over 6. Oh my gosh, no it's not. Did I mess it up here? No, no, no. Okay. Okay, that's why we're careful with our fractions, everybody. 5 pi over 6 is not right at all. 6 pi over 6 plus 1 pi over 6 would be 7 pi over 6. Hello. Did that wake you up? It woke me up. Sometimes you just go on autopilot. Boom. Those are our two answers. They're not other ones. If you wrote other ones, that's wrong. We're only between this interval. We technically could get the same angle again if we went over and over and over around, but we're not going to do that. Okay. One last one to try out. Really quick, this fact right here must be memorized. It's very common, and you have to use this one in your calculator. We've had this speech many times. Your calculator doesn't understand this. When you input something in your calculator, you have to type it this way. Please, 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 please listen to me. Go ahead and try to solve. We're trying to solve for theta. We are not using a calculator. We are not using inverse trig. Don't touch that cosine inverse button. Don't touch that cosine to the -1 button. It's wrong. 3, 2, 1. Just start by isolating cosine. Still isolating cosine. Take the square root of both sides, and now here's the part that everybody forgets. When you take the square root of both sides, you better have a plus or minus. Square root of 1 is 1. Square root of 2 is root 2. So now we have a lot of different options for our triangle. We could have a positive over a negative. We could have negative over positive. Basically, this gives us all 4 possible triangles. Man. Still getting used to this new tech. All right. Let's look at split realities. I think I'll draw my first triangles. Whoa, no, no, I want that line. That line was so good. All right, so we have option 1, cosine theta equals 1 over root 2. Now for all of these, we're going to have adjacent over hypotenuse, or the x-coordinate over the r, the radius. So positive 1 x value could be here. That's really the only way to get positive 1 x value. And a root 2 y value would be right here. So what's this side have to be? 1. It's the classic pi over 4 or 45-degree angle triangle. It would also give you this one. Its evil twin down here, I don't know, yeah, its evil twin down here, I'll use this, still has a positive x-coordinate but has a negative y-coordinate. Both of these would give you that same angle. Sorry, both of these would give you that same ratio where it's 1 over root 2. Confirm that. Both of these triangles would have its x-coordinate 1 and the radius root 2. So this would have theta equals, in happy quadrant 1, we have pi over 4. In quadrant 4, we could have 3 pi over 2 plus pi over 4. Or maybe slightly easier for you, 2 pi minus pi over 4. Starting from here, going backwards. Either way, it's, and now I'm really making sure I do this right in my brain, 7 pi over 4. Those would be the solutions for the green guy. Now, unfortunately, again, we have the evil twin, in this case, with the negative 1 over root 2. A negative x value and a positive root 2 as the radius. So that would be this, wow, okay. That would be this guy. So negative one side. Or this guy. They both have the negative 1 root side, and they both can have a root 2 radius. So all 4 triangles are possible now. That would be a positive y value, that would be a negative y value, but the y values didn't matter. That's why we have to have both possibilities for both of these. The y values were free. Over here, this blue triangle would be pi over 2 plus pi over 4. Also pi minus pi over 4. You would get theta equals 3 pi over 4. Or its evil twin, its little cousin down here, pi plus pi over 4, 5 pi over 4. There is no shame in watching this video more than once. There's no shame asking me for more practice on this. You should try the homework first. You should be able to do all the homework. If the first part of the homework gave you trouble, do that again. You need to know trig. You need to know trig at this level. It's really important. I'll leave you with this. Oh, not this. I'll leave you with, hello, this. Take a picture of this. Take a screenshot of this. This is something you must memorize. This is something that you are responsible for knowing by heart. If you have another way of memorizing it, go ahead. I don't really care. Some teachers give this hint. Some teachers will make you fill this out in like a minute and then just hand it in, and you'll have to just take the L, just lose points if you can do it. So please take this seriously. Please memorize this. Please come get help from Trig, get help on Trig from me if you need. It's not necessarily easy. It should be review. I'm sorry if it's not, but I can help you make it easy. It's not that bad. Have a good night. Have a good day. Do the homework. Do the homework. Do the homework. Bye for now.